Hello, it is around 9 p.m. Welcome to the weather update. We're dealing with some pretty gloomy weather, but very cool. I want to briefly go over the current conditions we've been dealing with today. And it's been a very cool day. We've only been in the 60s all day long here on Long Island. A little damp out there. Dew points are ranging from the upper 50s to low 60s. Um, and you can see we only barely hit 70 degrees today, so it's going to be more of the same for tomorrow because we have this stall frontal boundary along with the moisture from Gordon approaching our area. So we look at the radar, you'll see here that moisture. But the main thing that I want to talk about, of course, is Tropical Storm Florence. Now, it's still a tropical storm, and the advisory as of 5 p.m. Is 70-mile-an-hour winds and maximum sustained. So it's increasing strength, and it's moving as west at 5 miles an hour. So the strength is increasing, and it is slowing down. And if we look at the forecast here, you'll see that the forecast now has it hitting the Carolinas. All right, that is the forecast track on Tropical Storm Florence, and it is going to intensify once it gets out of the dry air and that dust as it moves west and gets over that warm water. It's going to take off like a rocket. I can guarantee it. Let's take a look at the satellite here, and you'll see still looks kind of disorganized. Looks quite disorganized actually, but like I said, it will be gaining strength again. Actually, yeah, let's do this water vapor loop because this kind of shows you. I want to kind of show you the dust in the dry air. See that dry air that came in with the dust? Those are two things that help weaken a hurricane. So when dry air or dust gets into it, it weakens it. You can see it's sort of almost barely moving. But once it moves over warmer water, it will pick up strength. And that's what's going to happen with that. So let's take a look at the models. Let's see where this thing goes. So we're going to go and we're going to change the regions to the, let's see, Eastern U.S. view. All right, yeah, we'll use this one. All right, so we'll use the Eastern U.S. view for the GFS as we track Florence. And this is the 18Z run of the GFS. So you can see it's tracking further south now. But the thing is, this run on the 18Z has changed. And now it's taking it once again a little further north, and then it's taking it almost up to, looks like Cape Hatteras, maybe maybe the Virginia coast, and then it's kind of stalls, and then it moves southwestward. It moves southwestward in a retrograding pattern, which is very strange. This would definitely be a devastating track for North Carolina for sure. And then it kind of sits over them. And then what winds up happening is it moves up the coast. And it keeps it fairly strong, which is very disturbing. So this would not be a good track for us at all. I mean, it would be weakened by the time it would get to us, but it would still be a very bad track for us. This is different from I haven't seen the 18Z run. I saw the 12Z run, where it had it stalled over the Carolinas and then took it back out to sea. Now it's taking it up the coast. This would definitely be very bad for us for sure. There's no consistency in the models; they change completely, and it's very hard to really get an idea of what is going, where this thing is going to go right now at this point. So let's take a look and see. You can see here, we're going to look at the wind field, and you can see here that this is a category, definitely at least a category 3. If not I think this is going to go back up to a category 4 personally. Yes, definitely. And you see what it does. It kind of keeps the center of it over the water, which is very bad because that means it's got the fuel it needs, the warm ocean, and it just has it sit over there. And then it moves it inland over North Carolina, and then it moves it up the coast. And if this scenario were to verify, we would have sustained winds of tropical storm force, maybe even minimal hurricane. This would be a bad track for us because it keeps the storm close to the water and keeps it from weakening. And that is definitely very disturbing. Now we're going to take a look at the Euro and see what the Euro has for the track. And again, this would be roughly Thursday, time frame that this thing would hit. So let's take a look at the Euro now. Now the Euro has it hitting North Carolina as well, and it looks like it has it doing the same thing, sitting there, but it has it weakening faster, and then it kind of just has it sit there. It doesn't move. And again, this is really unusual, and this is not normal, and this all comes back to the jet stream. Let's look at the jet stream here. I think this will give us a jet stream here. It may not give us. No, it doesn't give us the. Now GFS doesn't give us that. All right. Well, let me go to the last model, which is the Canadian. All right. And we'll go look at the. I don't know if the Canadian will give us wind. It will give us wind. Okay, so let's do that. All right. So let's see what the Canadian's track is. And this is the 12Z Canadian. It has it tracking into the Carolinas and sitting there. So they all seem to agree on it hit somewhere around the Carolinas, but where it goes from there is different. The Canadian still wants to take it like due west into Georgia. And this is because we have, again, a very strong ridge in a spot there. There's not supposed to be a ridge. And that all goes back to the jet stream. So let's take a look at the jet stream once again. We'll look at it on the GFS, and you'll see what the problem is. Alright, you'll see what the problem is. There is no jet stream. This is the problem. There's no jet stream over this area. And without a jet stream to move things along, we have to watch this too, by the way. This could be a very weak tropical storm developing here. We'll have to keep an eye on that. Chances of development are very small, but it seems like it wants to spin something up. Oh no, that is. I'm sorry. I do. Let me. I'll have to edit that out. So here it is. Here is Florence coming in, and you see what the problem is. There's no jet stream here to move things along, and without the jet stream being here to move things along, you see how wavy whatever is left of the jet stream is so wavy that it's nothing is moving, nothing is progressing from the normal, weather patterns that we have, and then it sort of slowly gets pulled off by a trough over here. Again, this is all screwed up. And again, the jet stream is, again, I'm going to actually pull this regions out so you can see here. We'll go to the North Atlantic view again and show you the jet stream at this time. And this is the problem. The jet stream, whatever exists of it, is just a wavy mess, and it's way up into Canada. So the jet stream is supposed to move the weather along from west to east, and this is not happening. Instead, we have the air coming from right up from the southeast, And this is all due to climate change, and the climate change is what I'm going to put the link to this article below. NASA discovers bubbling lakes in the remote Arctic. So these lakes are permafrost that hasn't melted for years. And it's been frozen all our lifetimes, and now it's starting to melt, and methane is escaping, and that's going to lead to runaway greenhouse effect. So you definitely want to read that, and that's why we're seeing what we're seeing, and it's like somebody flipped a switch. So here's another look at the wider view of the GFS, because I really want to show you the models. And this is again looking at the jet stream. You can see what is left of it over here, and you can, the jet stream is supposed to be a contiguous belt of high winds, but you can see it's all broken up. It's wavy, and that's why we're dealing with the stall front syndrome that we're dealing with now. And as we go into next week, you see there isn't a change. And we got this Atlantic ridge that's been dogging us for months now. And look at what the jet stream is doing over here. Literally, this is a kinked up, messed up jet stream. You're not supposed to see it ever do this. That is crazy. So there is Florence, and you can see this is what's allowing Florence and all the tropical air to come up, because the jet stream, which normally is supposed to be flowing, I'm going to explain to you in the next part how the jet stream is supposed to be flowing from west to east, but this is not normal at all. So this is what causes Florence to just get stuck and sit. We got a blocking ridge over here, so it just gets stuck and sit. That's not supposed to be what's happening, and this is the problem. Look at how wavy that jet stream is. Look at that. Literally, it's flowing straight up into northern Canada. The jet stream is nowhere around. The jet stream is supposed to be down here, all right? Whatever is left of it is supposed to be down here. This is all due to climate change, and as you can see, nothing really changes. we have continue with this wavy pattern here, with the and not having a jet stream, and this is very concerning. And this is why I'm trying to explain why this thing is heading toward us and why it's not heading out to sea. And this is very alarming. So let's go and look at the dew points to show you, because guess what's coming back next week? The humidity is coming back. Actually, I have to change the regions to CONUS because I won't display the dew points on that. But we'll take a look at this and see. Unfortunately, the humidity is coming back next week. So let's go. We got this weekend here. Let's go back here to today. And yes, it's been comfortable. The dew points have been lower, upper 50s to low 60s. And the dew points stay low tomorrow in the northeast. Because we got this backdoor front that's stalled out over just to our south. But then what happens is, as we get into Monday, the humidity starts coming back, along with the hurricane. Here we go again, dealing with the humidity again. Dew points probably reaching the 70s once again, and dealing with that tropical air again. And then there, of course, because it's going to be accompanied by the hurricane. It always usually is. And then this track here, you could see dry air trying to make an entrance, but you know, we'd have to wait until this thing passes, whatever's left of it. It could still be a minimal hurricane by the time it hits, if it were to take this track. And then it gets really dry afterwards. So it does get better after, but look at what we got to go through. And it's like the hurricane is actually the system that's actually going to bring down the dry air, not the jet stream, because it goes extratropical as it reaches New England. All right. Yeah, we'll go look at the temperatures. Line this back to today. Temperature shaded. We'll look at the temperatures. See, all right. So you know this weekend's going to be cool over the northeast. We know tomorrow is also going to be cool. Sunday and Monday, it starts heating up a little bit, but I still think we'll be in the 70s. And then look at what happens as we get to Tuesday. 80s once again with those 70-degree dew points. And look at that, 80s again for Wednesday, maybe near 90 in Jersey. We are now into mid-September. It's not supposed to, it's like way above what it's supposed to be. And Thursday, same thing, it starts cooling off as we get that, as we get the, you know, moisture from Florence, or whatever Florence is at this point. It's really going to be hard to tell. But you can see the cool air just doesn't want to come down. It doesn't start until Florence passes and then pulls it down. The jet stream won't be pulling it down. Florence will be pulling it down. The jet stream is, like I said, nowhere in sight, and this is really abnormal, and that's what's very concerning. And speaking of anomalies, let's go and look at this, which will be the temperature anomaly for our area. So this weekend we're a little below normal, but look at that. We're above normal by Tuesday once again. Wednesday, above normal. Thursday, above normal. Friday, above normal, and it starts cooling off a little bit. But again, highly abnormal weather that we're going through here. And this is all, again, due to the jet stream, which is, again, I guess I have to explain it to you again, don't I? I guess I do. Alright, I'm going to draw this graphic for you because I have to. You know, the only way people are going to understand what's going on. Because, again, this jet stream here, the jet stream, I'm going to show you what the jet stream is supposed to look like, and then show you what we're getting and why that is. So let me just start drawing the jet stream here for you. So the jet stream is supposed to generally look like this. Supposed to generally look like this. Alright. General west to east flow. You know, taking systems and fronts through. You know, this is what it's supposed to look like this. Alright? Supposed to look like that. But the problem is the jet stream doesn't look like that. And the jet stream is very wavy. Alright, so instead of having that straight west to east pattern, generally keeping systems like the tropical air away, we have a very weak jet stream. And the weak jet stream is very wavy, like this. Alright? And as a result of these waves and kinks in the jet stream, and that's what it looks like, because I'll just make it like dashed, because it's so diffuse and weak that it's not really carrying things properly. So you have you have these huge troughs and huge ridges going on in the jet stream, and it's all messed up. All right, and so as a result of this, the warm air that is the tropical air that's supposed to be kept here, like all here in the tropics, all the tropical air that's supposed to be kept here, is moving up. It's moving up in our direction. This is the humidity. This is why we have the extreme humidity and these hurricanes. They're going to come. Instead of making that right-hand hook, the jet stream would normally kick Florence out to sea. Normally, we'd have a jet stream that would kick Florence out to sea. So it would normally just kick this out to sea, and it would normally just kick this humidity out to sea. But instead, that's not happening. Instead, it's coming right up into the whole East Coast. And you're getting all this humidity into the whole eastern part of the country instead of it being kicked out to the southeast. Instead of that, so we're getting all this abnormal weather, the abnormal humidity, all this stuff, and it feeds on itself because it makes the water temperatures warmer, which makes it even more humid. All right? The jet stream is fed between the difference between the tropics and the poles. So normally, you have the difference in the this is where it's hot over here in the tropics, and in the poles is where it's cold. So it normally is cold up here. So you have the difference, and this difference fuels the jet stream. This fuels the jet stream. But the problem is it's getting warmer up here. And as it gets warmer up here, because it's getting warmer, there's less of a difference, and therefore a weaker, wavier jet stream. And this is the reason why we're seeing the weather patterns change. And it's almost like a switch has been flipped. And it's very concerning because we may be seeing a radical shift in the climate that's going to make the east coast of the United States become tropical. All right, and it seems like that is exactly what's happening. So in the next and last part of this video, I'm going to explain to you what the future may look like, what the future climate may look like here on the East Coast. Okay, so we're going to look and see what the future is going to be on the East Coast with this new climate that we have, right? And unfortunately, it's not good. For 6 months out of the year, the East Coast, generally I'm going to draw this in a line between here, probably here, yeah. Over here, probably, yeah. This whole area right here. And maybe even the part of Maine. Will be tropical, at least 6 months out of the year. So say from May, actually I'm going to change that to April. April through November, it will be humid. All right, very humid. All right, and what I mean by very humid, dew points of 75 to 80. That's going to be normal. Dew points of 75 to 80 will be a norm. All right. It will also be hot as well. Temperatures will run above normal. But generally, the most notable change is going to be the humidity. As a result of that humidity, there's going to be a lot more flash flooding. So, as a result, you're going to have more storms, all right, and clouds, of course. Clear days will be a thing of the past. All right. And the other thing that's going to happen, and now we get to the winter. What's going to happen in the winter? Well, in the winter, winters are going to lack extreme cold. So, generally from December to March, you're going to have like spring-like temperatures, 40s, 50s, and big wet snowstorms. So we're going to have big wet snowstorms, and that is going to be very bad for, it's going to cause tree damage and stuff like that, all right, because the waters are warmer than normal, and they're going to feed these snowstorms, all right. And because the waters are warmer than normal, the other thing that is, so you're going to have more nor'easters, more hurricanes, because again, nor'easters, easters, pardon my handwriting here. And I'll just put canes. Canes. All right, so generally more tropical systems are going to be coming up into the area because of, again, we don't have steering currents, so all the tropical air is just going to come right up into the eastern coast. There's nothing going to be stopping it because there's no steering currents, and the Atlantic Ocean is very warm. Now, as far as the west goes, the west doesn't expect the heat. The west is going to have hot, dry summers. All right? Summers. And probably cold, they'll probably have cold winters. And the reason why it's colder there is just because of the geography. All right, so the cold air is going to come down from Canada in the winter straight down. And the reason why that's going to happen is because it's easier for it to get down on this side of the country. All right? You also have the ocean waters here, which are generally cool. You have the ocean waters here that are cool, and you also have the mountains, big mountains. So the big mountains act as a barrier, except along the coast, but the big mountains act as a barrier to keep the moisture away from these areas. So these areas will stay dry and get drier. But the weather won't be as stormy here as it will be east, because again we have this, literally have this huge push of just tropical moisture, because the oceans are so warm here, and there's just there's nothing really to stop the humidity from just coming up and just turning this whole area into tropics. All right, there's nothing to stop it, and so we're going to have a tropical climate, and this is what's going to happen out west, where there's elevation and mountains. It'll protect you from the humidity, but it still could get hot. It could still be very dry in the summer. It means lots of fires. But the winters will get colder because, again, that warm air that's bubbling up on this side, that's another thing. Because the warm air is bubbling up on this side, it's going to push down the cold air on this side. So it's going to push down the cold air. But there's no jet stream to move things along. It's just going to be like a big Hadley cell. One side the warm air rises, then the other side the cold air descends. And most of the time, this is the way the pattern's going to be. And I'm really concerned this is what we're heading toward. And this is really, really disturbing, and it's gonna make the whole East Coast uninhabitable. Don't want to be Mr. Doomsday here, but this is why I just want people to take this seriously. I want people to take it seriously. So the last part of this video, I want to talk about what the government needs to do. And the first thing the government needs to do right now is declare a climate emergency. And if I were the President of the United States, I would issue the 3 following executive orders. I would order immediate tiered gas rates based on fuel economy. So if you have a car that's got good fuel economy, you're going to pay very low gas rates. But those with gas guzzlers are going to pay higher gas rates. So, for instance, all right, the gas price is probably, let's say, it's $3 a gallon. So instead, it would be $2.50 for a vehicle that gets at least 30 miles per gallon for gas, a highway. All right. But if your vehicle gets 20 miles per gallon on the highway, then you're going to be paying $3.50. And if your vehicle gets less than 20 miles per gallon on the highway, you're going to be paying $8 a gallon. So it's going to be the more of a gas guzzler, way more you're going to be paying, much more in gas. All right, now that'll be a gas tax, so it'll go toward mass transit that we're going to talk about later. All right. The other thing I would do is all vehicles would be hybrids by 2020. There would be mandatory. All vehicles on the road right now must be mandatory 30 miles per gallon. So by 2020, all new vehicles sold in the United States would have to be hybrids. And any vehicles that are on the road by 2020 would have to get a mandatory 30 mile per gallon highway or be taken off the road. They would be illegal to drive. And the third thing is I would order NASA to investigate active mitigation for climate change. So I'd tell NASA, you have 2 years to come up with a plan to cool this planet down. Whether it be spraying reflective particles in the atmosphere, finding ways to reduce solar radiation, and cooling the oceans down. All right? These are major things, but we have to do them to save humanity. All right? And the number two thing we need to do is fund mass transit projects. I would order the immediate restoration of all transit services cut in the past 10 years. So I would go over and we would look at every transit agency and what service has been cut, and we'd give them a timeline to say, you have to restore the service that you cut. All right, we will find the money for it, and we'll restore that service. Get people back on the mass transit, and that's way more efficient than having people drive and pollute the air with cars. And then the other thing I would do, and I would say within the next 3 years, I would make it mandatory that 90% of this nation be served by mass transit, some form of mass transit, whether it be bus or rail. We build new major projects, rail projects like they have in Europe. Of course, this is an agenda that most people in the government, Democrats and Republicans, balk at, especially our president. He would laugh at this. But this is exactly why Trump is a disaster I think it's actually gotten worse since he became president. And I have to say, I think Trump needs to be impeached. All right, I know some people are going to disagree with that, but I think he's very dangerous for the planet. And he's a danger to the world, by the legal impeachment process, whether it be articles of impeachment. I know they've talked about this on the news, but bottom line is this is what our government needs to do because we are heading for disaster, and we cannot have a world where New York is having a tropical climate half the year, and then in the winter having crippling snowstorms and warmth and humidity, constant humidity all year long. We can't have this. This is a global climate emergency, and I am asking everybody in the government, from the president to the Senate to the Congress, to declare a climate emergency right now. Right now. It needs to be declared because we need to save the humanity. If we don't, the longer we push this off, the more likely it's going to be that we're not going to be able to reverse this. We need to declare a climate emergency right now. That's going to be it for this weather update.